Hi everyone and welcome back. So as we discussed in the first video, we are going to talk about the 12-factor app principles with the nestjs. So what we are going to do in the initial videos, we will try to create a baseline of nestjs application with a simple routes. We will be using typeorm, we will be using Docker and all these things. So we will go one by one all these things, like first of all we are installing nestjs. What we are doing is first we will install nestjs CLI globally. Nestjs is a Node.js framework which will help us to write a simple microservice which we are going to use for applying the 12-factor principles, which is about configurations, version control, deployment, dev, production parity, and all those principles we are going to apply. So once that is done, we will just generate a simple project, and then after creating this project, we will do a lot of changes in this project for our requirement. Like we will introduce Docker, we will introduce typeorm with the postgres, we will write some of the APIs, we will write entities, migrations, seeders, test cases, all those things we are going to write. We are going to introduce eslint with this. So let's say if I create a project, then I think it will create a new folder. Or what I can do is I can go one step back and I can just do new nestjs CLI baseline. Okay, it will create a folder in my root, and yes, it has created some basic skeleton and it is using jest by default, and you can see it's a TypeScript project, so you will see all the different folders. Let's go to that folder. Okay, everything is cool. Now we can see we got a simple folder which contains a controller, modules and services. We have eslint already set up, prettier RC, nest CLI, package.json, tsconfig and all, right? Whatever the basic things which we expect, all things are available here. Now if you do npm run start, it will be able to bootstrap our application. Now on top of this, what we want, we don't want like the very basic skeleton. We want to introduce the typeorm and all these other libraries. So our objective is to make this application enough so that we can start building on top of this for other 12-factor principles. So what all things we have to do? We have to introduce Docker, all these things. So let's do one by one. I don't want to use an nestcli. Nestcli is just to show you guys how to get started with the basic project if you want to start from scratch zero. Okay, so this is our tsconfig file, and this is our package.json file. We have a lot of dependencies here, so these dependencies are fine, but we will also add few more dependencies on top of this. All right, we are using jest, we are using eslint, and you can see eslint RC here, which is dependent on the other eslint TypeScript plugins, TypeScript eslint. Now we are no more in the tslint world, we are using purely eslint. Some of the rules of eslints are disabled, and here you can see these are the plugins which it is extending, TypeScript eslint, and it might be having a script also for the lint inside the package.json. You can see npm run lint. It is using all the folders and it is applying fix. It is using jest for running the jest is a test runner, right? So we are using npm run test, npm run test watch, npm run test coverage, npm run test end-to-end. So for end-to-end test case also we can write and we can test. And format, it is using prettier, so we can stay with the prettier. It is a very nice tool, and it is using nestjs. Now like nest script, you might have used create react app, right? npm run build, npm run start, but I'm not a big fan of nest CLI, but yeah, big fan of nestjs. We can get rid of this particular script and the nest CLI.json because we have our own script. We have our own node mon which we are going to introduce. So we are going to introduce all these things together, like introducing the node mon, all the other libraries which we need for our application bootstrap. This video is going to be lengthy, so be ready for that. Npm install -- save nodemon. First dependency which we are adding, what nodemon will do is it can actually run the application in the watch mode, and we will also update our package.json and our tsconfig file. We really don't need two different configurations, tsconfig and tsconfig.json. We can just have only one tsconfig file, and here we can define the exclusion. You can see here, and I will explain what change we have done. So this is tsconfig. What it is saying, exclude all these things, include only those things which are coming inside src and test folders. Whenever I'm doing npm run build, I will create output directory dist, and this is my target, right? And my module, compiler modules, is CommonJS, and compiler is a TypeScript. Okay, I have src and I have a test. Now we are building a basic skeleton of our project. Now what we will do is we will introduce all the other files like .env.test. So we have added env examples. Now next thing we are going to introduce is Docker environment, because we want our applications to interface with the Postgres and typeorm. So all the other dependencies also we are going to introduce. The other dependencies are like what other things we are going to install is the typeorm, which is npm module. So we can open another terminal and put all the other dependencies which we are looking for in this project. So you can see we are going to have .env, so I will include all those dependencies one by one. Npm install -- save .env .env CLI, which is really very important module, and we are going to use PZ for Postgres, and typeorm, this is another module. Let's add that right now. Winston for logging, and Swagger UI Express, I think that should be already there. So install all these things, and then we need to look for what all test dependencies we need to add. Already jest is there. We will see all those things. So I will be splitting these videos into the multiple chunks because it is going to be very lengthy. So also introduce let's say for the testing, like type definitions for jest, type definition for ts node, all these things we are going to add. So let's now add a nodemon file, nodemon.json. So nodemon.json file will contain our startup script. So we already installed a nodemon module. What this nodemon.json will contain is what needs to be executing, what we are going to execute. Like we are going to watch src folder, extension is ts, and we are going to ignore the spec.ts while we are running the application. And what is the main file? If you see, main.ts is the main file for the whole application, and we are going to execute this. Okay, we will introduce few more packages. Let's go to our command line, and we will go to our package.json. We have TypeScript path, jest we have, nest CLI, typeorm, Postgres. Now we have added nodemon.env CLI. These are the core packages. Okay, we might need a few more packages, which is moment package we are adding, Lodash, eslint we already have in the dev dependencies. So these are the packages. Now if we go to the dev dependencies, here what all we have, we are going to introduce one more dependency, UUID, because we are going to have the UUID types. So what we will say is we will add UUID, then prettier, super test, and all the other dependencies we already have. We are using jest, not like NYC, Istanbul and Mocha. If we use all those things, then we have to add additional dependencies like jest, Mocha, chai spice, super test and all these things. So in earlier projects I was talking about NYC and all, but in this we are talking about only jest, and jest provides all different ways of mocking and all these things. Jest provides us a nice way to get the coverage, nice way to watch all the test cases, so we don't need to introduce all those sort of dependencies. We have introduced node moon. Okay, node moon is also dev dependency, not a main dependencies, so we'll just put that there. Node moon, the eslint we don't need. So okay, now we are good with the dependencies. Next thing we are going to do is introduce a Docker file. Okay, so for the Docker file, what we do is first we will create a Docker file. I mean, if you want to run your container on the Docker, then you can use this Docker file, and we are going to introduce the Docker compose. If you are not familiar with the Docker, then just have a look at simple Docker videos which I already provided. Then docker compose dot override, docker compose override dot yml, and docker ignore. Docker ignore we are using so that we can ignore the content being pushed in the Docker image. Okay, so docker ignore, we have all these files we have. Now we have all the runtime files like prettier rc, eslint rc, git ignore, env.example, all those things. What we are going to have in the env, if you just think about, it's only going to have only two arguments. Let's say env.example, we are going to have our database name, database URL and environment. Same thing we can copy into env, and we can have another environment file for env test environment, env.testing. That will have a test database. So the whole application is going to have two database. One is application database, another is a test database, because we are going to run the end-to-end test cases also. Okay, and we have src, test folder is there. Then let's set up a Docker. So we are going to create a Docker file. Docker file is plain and simple. We are going to create a Docker file from the base Buster Slim image. So this is our Docker file. So this is a basic Docker file syntax. What we are doing is we are creating npm install, copying the package.json. We don't have npm rc, we can comment this, and copying all the folder to app directory, doing npm run build, exposing 3000 port, and we also created a user for running this, and we are running finally npm run start prod command. Next thing is writing a docker compose file. Okay, so in docker compose file we can have both the containers running like node.js and the postgres. These are the two services we are going to have. So we can just say you do the build from the current working directory. Okay, and then docker compose override. Docker compose override means rest all the arguments I'm specifying in the docker compose override. I'm not writing it from the scratch because these things I have already covered in the couple of various nestjs videos where I'm using the nestjs with ORMs. So this is the node.js and this is the postgres. Node.js container name, what is the command, what is the environment, what is the port binding. Postgres, the environment variables about the database names, database password, user, and the volume mounting. Okay, and the ports. And for volume mounting, we are pointing to this entry point.db file where we have a script that will actually create the database. So I will just copy and paste this. Docker utils, and what the script is containing. These are just a setup, local setup how to do this, because now we are using Docker. When you do docker compose up, what we want is both the test database and the application database should be created. That script is written here because the Docker Compose is looking at this file and it will execute this create user database, right? For the number of database, we have 2 database in the Docker Compose file. For every database, it will create the database, set the user, set all the privileges for that user. Okay, so this is how we are doing. So when we do Docker Compose up, it will spin up both the containers, but we want to run node.js locally. We wanted to have the Docker Compose. I mean, for the ideal world, you will also want to have the node.js running inside a container. That is good. I mean, run everything inside a container. This is the node and we have postgres, and this is the volume mounting for the postgres. Okay, now when I do Docker Compose up, it should be able to spin up both the container, and once it is starting the node.js container, it will execute npm run start command. So we need to do the changes because now we are not using nest CLI. We are going to run the compiled TypeScript file. So we are using nodemon already. If you see in the nodemon, what we have put node, and we are using ts node. Ts node is already a dev dependency. If not, we will add. TS node is already a dev dependency. So nodemon is using TS node to execute our TypeScript code. Okay. So when let's add the scripts in the package.json. What your scripts will be? Okay, npm run start, npm run build. So when I talk about npm run start, so I will copy these scripts and I will remove the pre-built pre-scripts which we already had. So start prod, start debug. We are not using nest. We are using nestjs, but we are not using nest CLI scripts. This is by npm run start, and when you do debug, it will execute nodemon, means it will execute instructions from nodemon JSON. When you hit npm run tsc, when you hit npm run build, what it is doing, it is using TypeScript, right, to build the code which is written inside a src folder. It will build that. Npm run build prod, it is the same thing like build or build prod is same. Npm run start production. So when you do the build, you are generating the files inside a dist folder. You see, this is the dist folder, and inside this you will be running main.js file. So this is what this npm run start prod is doing, node dist main.js. So when currently if I execute npm run start prod, what it is going to do, it is going to use nodemon. You can see npm run start prod, or you can also do npm run start debug. On local environment, you will be doing npm run start debug. It is using nodemon, right? And if everything is fine, it would be able to execute main.ts from source. But when you are doing it on the production, do it through npm run start prod, right? What it is doing, it is using the compiled file dist src main.js. Okay, so this looks like our minimal setup we have done. When you are doing npm run start, npm run test, npm run watch, it should be able to execute test cases using jest as a runner. You can just do npm run test. What it will do, it will use jest as a test runner, and it will execute all the test cases which are returned currently in the unit test cases inside src, and the integration test cases from the test folder. In the test, you can see I have just e2e JSON. This file is explaining how to run the end-to-end test cases. When I execute npm run test e2e, it actually hitting the actual APIs and testing our code. I'm not explaining how the nestjs works. I'm just creating a baseline with you guys. You can call it as a boilerplate, which is having the Docker, typeorm configurations, ormconfig.ts and all. And all the deployment configurations, even the CI/CD configurations. So we can talk about the 12-factor principles. So let's add few more dependencies like class transformer, class validator, and some dependencies related to a Swagger. Okay, So what we will do is npm install ---- save class validator. This is our first dependency that is going to use to validate the request payload. So it is same as the joy module which we have, and then class transformer. So the module name is transformer, and then some dependencies related to nestjs swagger. So we are going to use these dependencies, nestjs swagger and nestjs typeorm. With the typeorm, we also need to use nestjs module of typeorm. Okay, and then we have to add a dev dependencies for the same. So here we can add npm install ---- save dev. So these all are dev dependencies, and the dev dependencies so once all the dependencies are installed, let's validate it. These are nest.js code dependencies: swagger, typeorm, transformer, and validator. .env to populate the environment at the runtime. Express is a framework. Lodash moment is the additional third-party libraries. Postgres, and this module is actually used to delete a files from a particular folder. RxJS for reactive programming. Typeorm is for nestjs typeorm. UUID and Winston is for logging. And these all are my dev dependencies. So I think dependency chapter is now we can close. Now let's introduce some configurations for the ORM. So as we have discussed, we are going to use typeorm. So typeorm requires orm config.ts. That file is nothing but that file talks about how you are going to put the migrations, how you are going to put all the seeders, subscribers, right, and how I can acquire the database connection. So this is a simple orm config.ts. What we are having is DB dialect is a Postgres by default. We will pass only one simple connection URL, not username, password, blah blah, 4 different arguments, just a connection URL. And then this SSL is required. I will talk about this later, like when we do the heroku deployment. Logging is true. This is the entity directory, means what all typeorm entities where we are going to keep them. So this is the folder where I'm going to put all the typeorm entities. This is the folder where I'm going to put all the migrations and subscribers. So this is the compiled file. This we are looking inside a dist, but in actual folder where it is going to be, inside src, I'm going to have app folder. This is going to be my actual folder structure for my application. Domain, inside domain I'm going to have other things like entities, and migration I'm going to have inside src. So I will create a folder, src migrations. Even we can have the subscribers. Currently we don't have any, but if we have typeorm subscribers, we can create a folder. That's it. Okay, inside domain we are going to have the other things also, like controllers, services and all. Services, DTOs, I mean all the building blocks which you see in nestjs. And src app domain, inside app I'm going to have other modules also, like auth module. Okay, inside app I'm going to have a db module, then logger module, all these things. I'm talking about the big picture. Okay, so what we have done, we have created typeorm configuration, and we have already decided the connection URL inside .env, like this is the Postgres API development password. Postgres is the container name. If you now go to Docker Compose override, here we have defined the password, the username and the database name. This is the application database, this is the test database. So we have all the three things. We can build the URL, and URL looks like this. Okay, this contains the container URL, but if you want to run it from the local, you can put the local host 5432. Now we have to check the mapping. For the host, you need to pass 5434, not 5432. 5432 is the container port. So if you want to run a connect to this container from outside, from your host system, you have to pass 5434. Let's say I don't want to use node.js on the container. I want to run only postgres on the container. Then I will just comment all these things or remove, and I will have only postgres configuration in the Docker Compose. Okay, this is my Docker file. Now most of the things are ready. I can actually do Docker Compose up. What it will do is it will look for Docker Compose YML file, right? It will see, okay, there is a Postgres container. Then it will check the override. It will see, okay, these are the username, password, and these are all the database I'm going to create. I think we already have this container running. So what we can do is we can do compose down. Compose down. You can install this Docker plugin, okay, Docker add-on or extension, whatever you call it, from the VS Code. And once it is done, we should be able to do our task again. So this is done. This is still running. Okay, now if I do Docker Compose up, what it will do is it will look for Docker Compose YML and it will see the host port is free 5434. Then it will start our containers. Containers is simple Postgres container that we are going to use for our Node.js application to connect through typeorm. You can see it is initializing the database, creating the database, and everything is ready. So we have two databases created, right? Starter API, and both the database are ready. We can check our post package.json. Currently we don't have a typeorm scripts ready. So what we will do is we will add the typeorm migration, seeders, typeorm CLI scripts in our package.json, and I will just copy them from my previous project. So here is our typeorm configurations. If you can see what all I have added: DB migration, DB drop, DB migration generate, DB migration create, DB revert, DB sync, DB migration run. So if you have any database migrations already created inside src, so what will happen when you hit npm run DB migration run? It is going to use typeorm command, and then using this typeorm command it is going to execute this migration. So this is how the typeorm command looks like. It is nothing but it is executing typeorm CLI. So typeorm migration run. Migration run will look inside ormconfig.ts and it will check where the migrations are kept inside dist folder src migrations. Dist folder src migration, there is nothing like that. So if I execute it right away, let's see what will happen. Now my containers are running. Npm run DB migration run. Okay, go to your package.json, DB migration run, right? There is nothing to execute, so no migration pending. But if you want to execute, create a new migration, you can create a new migration using this npm run test. It will actually create the new migration inside the src migrations folder. You can see this is the default syntax of typeorm migration, right? Now we will put the actual migrations, talking about a particular table having the primary key, foreign key columns and the other columns. Okay, for now we can delete it, it's not going to be used. So now you can see we have a migration setup, seeded setups and everything. Okay, now we have to create a folder structure of our modules, like what code we are going to write. Then we will create a test structure, how we are going to add the test we can use to write the end-to-end test, but for unit testing we will create all the unit tests in the respective folders. Like domain, we'll put controller test, services and services test. Okay, and here in the root folder we will have a domain module.ts. Okay, so objective of this boilerplate is just to explain you the cleanest way to construct a basic microservice. It will cover everything, all the testing, all the coverage scenarios, all the health check, all different things which are required, like different configurations for different environments, migrations, seeders, npm scripts to run the build, test, execute. Okay, all these things will be here. Okay, let's see that in the next video. Thanks everyone.